we're going to take a look how the proxy contracts like OpenZeppelin worked. What I've done, I've taken the function from OpenZeppelin and only taken the most core parts of it. First I'll demonstrate and then explain the code. So we have a proxy contract here and we're going to deploy that. So that's the outside interface. And then we're going to take that address and say that contract version 1 is deployed at that address. So in Remix we do that like this. So we take this contract and say it's deployed at this address. And now over here you see the interface of that contract. And we are going to retrieve this value. That's the V. And that's currently proxy, and that's the one from here. So that's the value from the proxy. So now this is just the proxy. Now we're going to link version 1 of the contract to it, like this. So it has been done. And we are going to call the version from that. Then we take a look at V, and suddenly we see version 1 over here. Now we're going to link the second contract, call this, and now we see version 2. So we see the functionality happening. So what's actually going on? So we have two contracts over here. I've put them on one line so they fit on the screen. So this is a contract. This is an event log. This is a variable called v, and here's the function called the function version. What it does, it sets the variable v to the version of the contract, and it also does an emit so that we can double check the log files. And version 2 does the same, but then with version 2, so we can see the difference. So and here's the proxy contract. Over here we have the two functions setv1 and setv2. What it does here, it sets a relay with the address of a contract of version 1 and version 2. So this updates the contracts to either version 1 or version 2 every time it makes a new version of that contract. So it calls the function setRelay, and setRelay is over here with parameter address. And what it does, it uses a slot. We'll come back to that a little bit later. So that's a place somewhere in memory. And then we use a little bit of assembly to address that. And what it says, it stores on that slot in memory the new address version. Okay, now we have set the address, and now we're going to call this function version. So that's this version, but initially this is linked to the proxy contract. So we're actually going to call the function version of this proxy contract. But if you look carefully, there is no function version in here. So how does that work? Well, now we're bumping into a special feature of Solidity, and that's the fallback function. So when you try to call a function that doesn't exist, then the fallback function is called. So then you end up over here. Now the first thing it does is call the getRelay. So that's this function. It goes to the same slot as the setRelay, and using a little bit of assembly, it loads the value from there. So it actually gives back the same value that you put in setRelay before. So the end result is that in implementation here we have the address of either version 1 or version 2 of the contract, or any additional versions. We log it so we can check later on what's happening, and then we are going to do this. That's actually another trick. We're going to call this function from via this address implementation, and then we are going to do delegate call. So we are not just calling a function over there, but we are delegating the call while we use the memory space of this current address. So the variables are stored in this address in the proxy, and the functions are run from the contract that you supplied. And it's relevant that you keep the variables in the same place, so that between upgrades of the contract you keep the same variables. So we call function in the other contract and we get the result here. So we get a success and also some data. So there could be data returned from that function call. But we're ignoring that for now. And we're checking the result here. And if it's not success, then we revert the function. So we get an error. So let's try it again. So we call version over here. Then we're going to look what's happening over here. And we see here the log output. And we see two log events. One is for an address. So that's this address. And that's the address that has been generated in here. And then we also see a log of a string. And so the address that's logged over here. And the string is logged over here. So from here we end up over here. And then the version variable is updated to version 2. So if we call this, we see version 2. And if we switch over to v1 again, then we can double check with the get relay. So we have a different address now, a1. And we are going to call version here. Check out the log. So it's to a different address. It's starting with a1. That's the same one as this. And we have a version of version 1. So if you call v now, we see version 1. Then back again to v2. Get relay, we have an updated address here. Call this again. Check here. Here you see the 9.3 address, version 2. So this is back to version 2. And if you call the v directly at the proxy, we get the same value. And that's obvious because this actually is exactly the same contract. You can see that over here. This is 1D1 and this is also 1D1. So that's at the same address actually. So those two are the same. Okay, so we've seen a few tricks already. And the last trick is this trick, the slot of the memory location. So with this construction, we are all working in the address space of the proxy storage. So in every contract you should have the same memory layout. So we have here in this contract a string v, in this contract a string v, and here a string v, and they're all the first variable, so take the same memory space. Now we want to remember the implementation position, but we don't want that to overlap with any other addresses. So there's a trick. If you put a position, we put that in a random piece of memory. So we take a string, call the hash function on it, and then we get a sort of random address, not really random because it's based on this, but it's sort of random. And then you can use that over here. So this stores the value somewhere in memory that's not going to overlap with anything else. So that's all the tricks that go into a proxy contract.